Hey everyone, in today's video, I'll show you how to 3D print a headlamp washer cover for a car bumper using the new budget-friendly Creality Pika scanner. We will test how well it handles tight fit tolerances when scanning with just a mobile phone. At first glance, the cover might look simple, but car bumpers don't have flat surfaces. The edges of the cover are actually complex 3D curves to make it sit flush against the bumper with the right gap. You need a precision 3D scanner and some reverse engineering in CAD. Let me walk you through how I have set up my mobile phone with the Pika scanner. Here's a ULancy phone bracket. It's made of aluminum and has a 1/4-inch female thread on top. And here's a male-to-male 1/4-inch thread which I will mount on top of the phone bracket. This is the Falcon F38 quick release base, a mount that's widely used on camera. I mounted on the 1/4-inch thread adapter. This is the F38 quick release plate and I'll be mounting it on the Pika. Be cautious when attaching your phone. The bracket can press on the power button and cause damage. And now you have got a compact mobile scanning setup. Let's powering it on. You should turn off your mobile network because sometimes it interferes with the Creality Scan app. Wait until the Pika hotspot shows up, then tap to connect. Then launch the Creality mobile app, which you can download from the Google Play Store. It should connect to the scanner within a few seconds. I recommend swiping down on the scanner screen to open the setting page. The phone won't cast a live preview to the scanner's smaller display, and this helps save Wi-Fi bandwidth for scanning. This setup lets me scan with one free hand, so I can control the app interface or turn the turntable. And it grips securely since I can rest my fingers right here on the phone bracket. You can also connect the Pika to an Android phone using a USB-C cable. It will connect instantly. But since I'm right-handed, the cable gets in the way and the scanner doesn't run any faster than over Wi-Fi, so this isn't my preferred option. This setup weighs 661 grams including the phone, so it's about 200 grams lighter than the Samun P1. And it's 100 grams lighter than the new 3D Mega Pro Turtle. I'll start by placing 10 mm sticker markers around the opening. There are two notches here where I can place the lock clips, and I don't need to scan the backside. The surface is quite glossy, so I used spray to save scanning time. Place the marker first, then apply the spray. Click on Start a new project. I'll scan in laser mode at 0.15mm resolution. You will notice I don't have screen casting enabled on the Pika. I prefer to watch the phone display. Casting to the Pika screen would consume Wi-Fi bandwidth. You can't toggle off screen casting, but simply swiping down to the setting page will stop it. I'm using a gaming phone with a Snapdragon 8 Gen 5 CPU and 16GB of RAM. The scanning speed is 40 FPS, which is impressively fast for an Android phone, and it runs smoothly without any hiccups. There's one mistake I made here, was forgetting to turn on automatic exposure. And if I turn this on, I wouldn't need to use the display at all. In the infrared preview screen, look for the small sun symbol. Make sure it shows the letter A, which indicates automatic exposure mode. Let's do the post-processing directly on the phone. I won't be using the Creality Scan PC app in this demonstration. In the Fusion tab, I set the resolution to 0.15mm and leave noise removal at its default level. Fusion time is quick because this is a small scan. It finishes in under a minute. Here's the mesh result. The scan produced 1.5 million faces, which is dense enough for a model of this size. I'm going to trim it down using the lasso tool. Then I use the inward selection tool to grab the opposite. then hit the delete key and finish. The scan looks very clean with sharp corners. Since I only made one scan, the app automatically generated the mesh right after fusion, so there is no need to run the mesh function. I click here to export the mesh to the PC. You can export either the mesh or the point cloud directly from the phone app, but you need to click on the single model tab, and there you will find a sub-menu to choose the model to export and set the export file type. I'll select the ASC point cloud format. Click on share, and the app will create a zip file. Then I'll send it to my PC using the quick share app from Google. Tap on my PC in the same Wi-Fi network. Next, I drop the ASC file into CloudCompare for alignment. Here, I can clearly see that the edges of the cap form 3D curves. So I need a CAD tool that supports patch surface creation and works directly with point clouds. That narrows it down to Autodesk Inventor and BricsCAD. Okay, let me change the color to the green bright color. I will align this bottom mounting face to the XY plane since it's flat. Here's a second point. Here's a third point. So I need only 3 points to align it to the XY plane. And this process is unnecessary, but I want to adjust one side of the cap to align with the x-axis. You can see here that the bottom face here is flat and is now level to the XY plane, but the top face they have curve. I think it's about 1 to 2 millimeters in variation. Next, I will export the file in LAS file format, which is recognizable by BricsCAD. Here in BricsCAD, I start by importing the point cloud. If you want to follow along, I put a co-file download link in the description. I'm changing the point size to 1, so it's smaller. Next, I crop the point cloud using the polyline options and keep the inside. And from the front view, I'm going to crop just the bottom portion of the point cloud. Then toggle on eSnap 3D, use UCS origin and move the UCS plane here. Turn off eSnap 3D and I use the polyline in the draft menu to create segments along the profiles. So this bottom face is not going to be visible, so it can have gap, and I don't have to trace it precisely. And I use the add bulge command to convert the segment into curve. Just hover your mouse over the lines and use the quad menu to activate the command. If there is a point that it doesn't look tangent, you can just pick on the node and slide it until it's smoothed out. Okay, next I'm going to offset the profiles by 0.2 millimeter. I just want to be sure that it will be smaller. Next, turn on eSnap 3D and use the UCS origin to move the coordinates here. And I'm going to create a straight line for 2 millimeters. Then I'm going to move the coordinate to the end of this line using the UCS origin command. Next, I will crop the point cloud, just the top portion. And I'm going to hide the first profile I created. So I do it similarly, just a trace with the polylines. But this time I do it more precise because this is the top face of the cap and it should create even gap. So it will look more professionally made. Here the same approach, I use add bulge command. So when your scan data is clean and noise free, it's very easy to trace the line. And this edge is round, it's already round, so I won't be making any line offset. So this top edge is going to be a tight fit, same as the original design. So we can also check the precision of the Pika when using with the mobile phone. Now I have two sketches profile, one in the bottom, one on the top. The UCS is already on this sketch, so I can activate the region command directly. Just turn on the selection mode. For the bottom sketch, I need to select the UCS entity first, then hover the mouse over the sketch profile to create the region. After I try to execute the loft command, it shows that I need to use the guide rail because the number of segments between the two sketches are very different. So I simply create 4 straight lines between the two sketches and run the loft command again and use the guide rail. Next, I'm going to hide it by turning off the layer visibility. Next, I'll turn on the eSnap 3D and I'm going to use the spline to snap around the edges of the cap. So this spline will fit to the surface of the bumper around the cap. So I have a closed profile made with the 3D spline. Next, I'm going to create a guide rails along the narrow side just to flatten the surface. In the Surface tab, click on Surface Patch, click on Curve, select the spline and then select the guide. Click on the guide and select the 4 straight lines to flatten the surface. Now I turn the solid layer back on. Click on the Slice command, click on the solid first, then select the surface to slice it. Then select the side to keep. Next, I'm going to hide the surface that I use for cutting. Now the top of the solid, the gray color solid, will have the same surface profile as the bumper. Now I'm flipping to the bottom side. I use the UCS face to move the origin to this plane. Then I create a line along this notch and offset it by 3 mm. Then I close the profile with another 2 lines. I do the same here on this side. Turn on the solid layer visibility. Toggle on the selection mode and select the 2 profiles. Then I use the push-pull command to pull it up by 3 mm. UCS face here. Create a line on this corner and offset it. Offset for 0.8 mm. I use the push-pull command to pull it 0.8 mm. Actually, this point I should have pulled it like 1.5 mm because the bumper plastic is very thin and I can do more overlap on the clip. I think 1.5 mm would be the perfect number. I make a chamfer here so I can push in the clip easier, and one more chamfer here. The clip is too long, so I will push it by 2 mm on each side to make it shorter. Here another side, 2 mm. And I do it similarly on the clip on this side. It's only 2 clips. I think it's enough to hold the cap. Okay, next I will add the chamfer at the bottom corner for 0.5 mm. Next, I'm going to create a profile on the bottom face here so that I can cut it down, make it hollow. Because I will print this with the resin printer, so making it hollow will save some resin. Because right now the cap is about 8 mm in the thickness. I use the push-pull command to push it downward by 4 mm. And this will save some weight. Next, I'm going to export the file as the STL file format because the Chitu Box, the printer software, has issue with the step file, so I need to export as the STL mesh file. I choose the highest setting so that I can get the highest resolution. Okay, here in the Chitu Box is a free version. I never feel like that I need a paid version for this software. It has the automatic orientation, so I click it a few times to choose the best one. And it can also automatically generate the support. Okay, now it's ready to be sent to the printer. I'm using the Phrozen Sonic Mighty 16K. It was provided to me by Frozen early this year for using in my project. I'm using the Aqua Hyperfine resin. If you are printing with a resin printer, you need mechanical ventilation. Just opening a window isn't enough to clear the fumes. The printing took over 4 hours, but the result is very rewarding. This cap has a very tight clearance and an FDM printer simply can't achieve that level of tolerance. Most people avoid resin printing because of the strong odor, and the post-print cleaning is heavy work. The post-printing process took me about 45 minutes including cleaning. But look at the result. The finished part requires a little to no sanding and is already ready for primer and top coating. The intricate details on the clips are razor sharp and the sidewalls are exceptionally smooth, something FDM printers simply can't reproduce. There are no visible layer lines or steps even along slide curves. And as I showed at the beginning of this video, it fits perfectly. There is no visible gap at all. The Pika's precision is excellent. The clip should have a bit more of the overlap, about 1.5mm would be ideal. Here's how I create a 3D printed headlamp washer cover for the bumper using the budget-friendly Pika scanner. Thanks you guys for watching. I'll see you in the next video.